I will today aim to solve some problems from the book by David Hotel. First problem is that so that px equal to x cube plus 9x plus 6 is irreducible in qx. Then I need to show that theta be a of px and the inverse 1 plus theta in q theta. That thing I need to show. So x cube plus 9x plus 6 is irreducible irreducible in qx follows from Eisenstein criteria, right? With the value of p equal to 3, because see, the coefficient is 1, 3 does not divide 1, and 3 divides all other things. So the coefficient of x square is 0, and other is 9 and 6. So 3 divides all the things. And 3 square, which is 9, it does not divide 6. So I can take p equal to 3 here. Okay. Now, theta be a root of px. That implies this thing, which implies theta cube equal to minus 9 theta minus 6. Okay. We have seen that q theta, it is irreducible. So q theta is actually a plus b and degree 3. So c theta squared by r. A, b and c are from q. That we have seen. We have done this. Let a plus b theta plus c theta square into 1 plus theta equal to 1. So let this is the inverse. Assume this is the inverse. So if we multiply and split this, that will give you a plus a theta plus b theta plus b theta square c theta square plus c theta cube equal to 1, or implies that. Implies that or everything, anything. So a plus a theta now see that, sorry, c theta cube is minus 9 theta minus 6. You can name this. Now subsequently it will give you now gathering all the terms together. So it will give b plus c theta square plus theta. Theta means a plus b minus 9c theta plus constant terms a plus b minus 6c equal to 1. So compare the powers of theta both sides. Equal to minus c. A plus b minus 9c equal to 0, or a equal to b equal to minus c, so equal to 10c, and a plus b minus 6c equal to 1. So put the value of a and b here. A means 10c, b means 9c, b means minus c. It's 3c equal to 1. Okay. So it gives us, it implies that c equal to 1 by 3, b equal to minus 1 by 3, and a equal to 10 by 3. So the inverse of 1 plus theta is theta square minus theta plus 10. Okay, so I think I have mistake, silly mistake. Sorry. Sorry for that mistake. There is no c. Okay. I think a minus 6 is 1. A is 10c. Minus 6c is 1. That means 4c is 1. So the values will be changed. This will be, I mean, c equal to 1 by 4 minus 1 by 4, and a is 10. That means 5 by 2. That is uh, uh, 5/2 minus theta by 4 plus theta square by, that is the answer. Okay, now I think it is correct. Just check if any mistake is there. Inform me later. Next problem is so that there is irreducible over F2 and the theta be a root, compute or so theta in F2 theta. So I told that already. F2 means Z mod 2Z, which is 0 bar 1 bar. Don't get confused. What is a relating? What is F2? Solve this. So as theta is a root of x cube plus x plus 1, we have theta cube plus theta plus 1 equal to 0. Obviously, theta cube means minus theta minus 1. But see that 1 means 1 bar. Here 2 bar is 0. 0 bar. So minus 1 bar means 1 bar. So minus 1 means plus 1. Because we are in Z2. In Z2, minus 1 and 1 are same thing. It is, we are not in Q or R or C. So we have to find out the powers of theta. That means theta to the power plus theta. Theta to the power 5 means theta cube plus theta square. But theta cube means theta plus 1 plus theta square. Theta to the power 6 means theta cube plus theta square plus theta, which means theta cube means theta plus 1. So it is theta plus 1 plus theta square plus 1 plus theta. That means theta square plus 2 theta plus 1. But 2 means 0. So it is this thing. What is 7? Again, multiply both sides by theta. You will get theta square plus theta. But theta square plus theta means minus 1. Theta square plus theta means if you take the 1 this side, it will be minus 1. But minus 1 equal to 1, I have told you. So that means this is 1. Okay. And theta power 8 means theta. In this way, it will revolve. Theta power 9 means theta square, theta power 10 means, sorry. So that is much, because the different powers, why I'm not writing theta power 8 equal to theta, because theta power 1 is also theta. Theta power 2 is, theta power 9 is theta square, but theta square is ordinarily theta square. So that are repeating after a certain step. After theta power 7, everything will be repetition of the lesser powers of 7. So the different powers are these things up to 7. So the different powers are theta 1 equal to theta. So in theta square, there will be not a problem. Theta square. But in theta cube, it is theta plus 1. Theta to the power 4 is theta square plus theta. Theta power 5 is theta square plus theta plus 1. Theta power 6 is theta square plus 1. And theta power 7 means 1. So they are the different powers. I don't need to calculate theta power 8, theta power 9, theta power 10, because that will be inside this set. Understand? Okay. Next problem is directly that this is easy. Now observe that q root 2 will be of the form in element a plus b root 2, where ab belongs to q. Okay. So it is easy, I think. If high q root 2 to q root 2 high a plus b root 2 goes to a minus b root 2, then higher. If I take two elements, a plus b root 2 plus c plus b root 2, then psi, it will be psi a plus c root 2 plus d, which is by definition of psi, it is a plus c minus root 2 d plus d. That means this is a minus root b root 2 plus c minus d root 2, which is equal to psi of a plus b root 2 plus psi of c plus d root 2. So additive structure is there. Now multiplication. Now psi of a plus b root 2 into c plus d root 2 is phi of this pi, okay, not psi. Psi is something different. Psi is no, I mean the notation is phi. So it is AC plus 2BD plus uh, that is this thing plus root 2 into AD plus BC. That is, so what is the, where phi will map it? Phi will map it into, sorry, then phi will map it into where? AC plus 2BD minus root 2 AD plus BC. But observe that this is the multiplication of A minus B root 2 C minus D root 2. That means it is so psi also preserves the multiplicative structure. Now into so that it is 1 1 and on 2. What is kernel psi? Or okay, now let psi of A plus B root 2 which imply that A minus B root 2 equal to C minus D root 2, which imply that A minus C equal to root 2 B minus D. Now, if D not equal to D, then root 2 equal to A minus C by B minus D. Is that root 2 is rational is a contradiction. Thus, B equal to D. That means now if we put B equal to D here, that side is 0, so equal to C. So A equal to C. Thus, A plus B root 2 equal to C plus D, which shows that psi is 1 1. Now I need to find a I need to show it is on. It is easy, very easy. For a plus b root 2 belongs to q root 2. Onto means in the codomain. If from codomain set I take any a plus b root 2, then its conjugate element is codomain. Domain and codomain are same here, okay? Phi of a minus b root 2. That means phi of a plus minus of b root 2. That will be a minus minus b root 2. That is a plus. Okay. So psi is on to hence psi is a isomorphism. That means psi is a homomorphism. Next problem, we need to show that suppose alpha is a rational root, a monic polynomial in, suppose I need to show alpha is actually an integer. So let alpha equal to p by q, where q non-zero and GCD of pq is 1. I need to show that, okay, let the monic polynomial be, let the monic polynomial be, let it be, monic means the leading coefficient is 1. A 0. Fine. Then put p by q here. Now I can write that I am multiplying both sides by q to the power n minus 1. So I am getting this, that is okay. So this gives, so observe that this from z, this is also from z, or natural number, more things. Or z, you can think this there from z, z. So the whole thing is from z. So this thing also might be from z. That means q divides p power n, but p, q are co-prime. P and q need not be prime, but they are co-prime. We will so now as p, q is co-prime pair, p to the power n and q is also prime pair. Okay. My target is to show q is 1. So how I am writing this? Because each co-prime means there exists q and v belongs to z such that pu plus vz equal to 1. Oh, sorry. Now that means pu 1 minus qv. So p to the power n, q to the power n equal to 1 minus qv whole power n. That is 1. Now if I restrict the exclude the first term 1 in the binomial expansion, every term will contain q. So it is q into some k. Alright. If it comes to z, that means p to the power n, q to the power n plus qk is 1. That means they are co-prime. Understand? They are co-prime. So that thing is integer. This is an integer that belongs to z, and these things are co-prime. So we must have q equal to 1. Then we must have q equal to 1. I mean, you can take also q equal to minus 1, then minus sign is transmitted to the p. So q equal to 1, and hence, and so e by q is an integer. Next is, next problem. so that if alpha is a root of this equation, then A in alpha is a root of the polynomial x to the power n plus a n minus 1 x to the power n minus 1 plus a n a alpha to the power a n a n minus sorry a n minus 2 x power n minus 2 plus plus a n minus 1 is their answer is it is very much is the problem. It is nothing to do with the field theory. Okay, I mean you multiply place alpha here. Okay, multiply both sides by a n to the power n minus 1, I think. Then it will get you a n alpha to the power n plus the constant term will be then a n n minus 1 a 0. And you will get. So it is easy. Clear. Six. Prove that prove that that x square cube minus nx plus 2 is irreducible or n equal to. So we know that there is a connection between reducibility in Q and reducibility in Z. Okay, so nothing is mentioned. So we can assume that reducibility in ZX or QX. I mean they are same sometimes, not always same. Okay, but okay, no problem. Not always same. Why? Because it is reducible in Z, reducible over Z, because I can split it. This is non-unit, this is not unit. So it is reducible in ZX. But over QX, I think it is not not reducible. So it is irreducible. Okay. You understand what I am trying to say? I think you understand. Actually, when does it hold? What I told you, that for 2x plus 2, that is different for QX and RX. Sorry, ZX. So for them, that is, for it that is different, but they are same if it is a monic polynomial, or if it is a primitive polynomial. Primitive means the GCD of the coefficients is 1, then irreducible in QX and ZX becomes same thing. What is the answer? So irreducible in QX, that means It is degree 3. So I can proceed by root test. Root means if it is reducible, then it has a root inside Q. Root in Q. But let P by Q be root of and Q is non-zero. What is the what is the main the thing then? We will apply a thing, rational root theorem. It says that if P by Q is a root of this equation, or satisfies the equation, it is a root of this equation is invalid sentence, is a root of this. Then I'm going to make it highlight. Then P divides A0. P divides AN. That is the statement of the theorem that we will apply here. So applying above theorem, we have P divides 2 and Q divides 1. That means P equal to plus minus 2 plus minus 1 and Q equal to plus minus 1. That means what is the choice of P by Q? Choice of P by Q is plus minus 2 and plus minus 1. So if P by Q is 2, then 2 cube minus n into 2 plus 2 equal to 0, imply 10 minus 2n equal to 0, imply n equal to 5. If P by Q equal to minus 2, then minus 8 plus 2 plus 2 equal to 0, which imply that n equal to 3. If by Q is 1, then 1 minus n plus 2 equal to 0. Which will imply that n equal to 3. Same thing, we are not getting new thing. If P by Q equal to minus 1, then minus 1 plus n plus 2 equal to 0, or n equal to minus 1. So we got the required proof using this thing, rational root theorem. Last problem. that answer. See, reducible means it can be split into two smaller factors. So if the smaller factor is the 5 degree, so the splitting will be either 1 plus 4 or 2 plus 3. So if it has a 1 degree factor, that means this has a root inside Z. I mean inside Q, this is a monic. So I can work inside Q also. That means this is a root inside Q. But this is a root inside Q means if P by Q is a root belongs to Q, then by this rational root theorem, P divides -1 and Q divides 1. Okay. Let P by Q belongs to Q be a root of x to the power 5 minus. For rational root theorem, P divides a constant. Divides -1 and Q divides 1. So P by Q can be 1 or -1. If by Q is 1, then put 1 here, the root. That means 1 minus ax minus 1 equal to 0. So x will be 1. This thing, that means a equal to 0. A equal to 0 case is done. If P by Q is -1, put -1 here. You will get -1 plus a, -1 equal to 0. A equal to 2. Now, so from splitting of degree 1 and 4, I can get up to this. And whatever if it is degree split, it splits over two polynomials of degree 2 and 3. Let degree 2, so let a0 plus a1x plus a2x square into b0 plus b1x plus b2x square plus b3x cube equal to x to the power 5 minus ax square. So what is this thing? Let me calculate separately. Is a0 b0 plus a0 b1x plus a0 b2x square plus a0 b3 x cube. That next is plus a1 terms, a1 b0x plus a1 b1x square plus a1 b2 x cube plus a1 b3 x power 4 plus a2 a2 b0 x square plus a2 b1 x cube plus a2 b2 x to the power 4 plus a2 b3 x to the power 5. that is the sun. So constant term is A0 B0. First degree term. What is the first degree term? This is degree 1 term. This is this and this. That means A0 B2 plus B0 A2 plus A1 B1 plus degree 3 term A0 B3 plus A1 B2, sorry, plus A2 B1 plus A3 is not there, so plus degree 4 term A0 B4 is not there. A1 B3 plus A2 B2 plus this 2. And degree 5 is A2 B3. So let me just for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 term is there. And there is also 3 terms into 4 terms. So 12 terms. So my calculation is correct. So from there I can compare, and comparing I can get comparing A0 B0 is 1. So what is the so I'm coming from backwards. What is this? Comparing I can get degree 5. So A2 B3 is 1. A1 B3 plus A2 B2, this is 0. A0 B3 plus A1 B2 plus A2 B1, this is 0. This is square term. A0 B2 plus B0 A2, A1 B1, this is also 0. A0 B1 plus A1 B0 is minus 1. Minus A, I think, na? Minus A. Lastly, last is A0 B0, which is minus 1. Okay. So I need to solve everything from there. I need to solve the systems, first of all. You can substitute the value consequently and get. So my target is, I will not either eliminate B from everywhere or either eliminate A from everywhere. So I will try to eliminate B. See, B3 is 1 minus A2. So A1 B3 plus A2 B2 equal to 0. That will imply A1 by A2 plus A2 B2. This is 0. That will imply A1 plus A2 square B2, that is 0. Then what is B2? B2 is minus A1 by A2 square. Just take the, be careful about this printing silly mistake. Okay. B2 is gone, B2, B3 is gone. What is B1 then, right? B1. B1. So I have used this equation, this equation. Now B1 can be related, we can get B1 from this. So what is B1? It implies A0 B3. So what is A0? B3 is A0 by A2 plus A1 B2. What is A1? A1 into B2. B2 is that A1 by A2 square plus A2 B1. A2 B1. B1 is not known. I need to find out. That will imply A0 by A2 minus A1 square by A2 square plus A2 B1. This is 0. That will imply, what is B1 then, right? B1 will be divided by A2. 1 by A2, 1 by A2. So actually we can do much better. We can do much better here. What we can do much better? Actually, that is much heftier. So it is a monic polynomial, right? So I can take the leading coefficients of the both polynomial B1. I mean A2 and B3 are 1 as unique. We can take A2 equal to B3 equal to 1. We can take. Then the equations will become A2 and B3 is 1. So A1 plus A carrying. That is not needed here. A2 B3 is 1. Then what is the sets of the polynomial? Then the set is, this thing is A1, B3 is 1 plus A2. Sorry. So this thing is, I mean, B3 and A2 are 1. So B3 A1 plus B2 is 0. B2 is minus A1. A0 plus B3 and A2. So A1 B2 plus B1 that is also 0, or A0 plus A1, B2 means minus A1 plus B1 that is 0, or B1 is A1 square minus A0, and B1 we have got. Now what is B0? Now I need to, my target was to get everything. B1, B2, so B3 I have got, B2 I have got, B1 I have got, so B0 is remaining. So B0 I can calculate from this equation. A0 B1 plus A1 B0 equal to minus A, or A0 is A0, B1 is A1 square minus A0 plus A1 B0. I don't know whether I'm something doing wrong. B0, A0 B1, A0 B0 is there. So let me check. Actually, I need to find out the value of A. So I will not, I will not, I don't want to use the equation here. So instead of this, let me use, okay, so you are stuck here. Let me proceed. So from these above two equations, just a minute. So from above set of equations, we determine the value of B2 and B1. So we need to determine the value of B0. And putting the value of B0, B1, we will get the value of A here. So to determine the value of B0, we will use this equation. So I need to write the name of the equation, but I will gently mention by highlighting them. So from this equation, I have B0 A2 equal to minus A1 B1 minus A0 B2. Yeah, now it is fine. Minus A0 B2. But A2 is 1, that implies B0 will be minus A1. B1 is A1 square minus A0, and A0, what is B2? B2 I am getting here minus A1. Oh, B2 is minus A1. Fine, so let me develop this, which implies B0 is minus A1 cube, minus and minus will be plus A1 A0, again plus A1 A0, which imply that minus A1 cube plus 2 A1 A0. So if I take common here A1, I will be getting A1 into 2A0 minus A1 square. This much is fine. Okay. So it is value of B0. Now I have also got A0 B0, I think minus 1 or what? I think minus 1. Yes, minus 1. So it is minus 1, which implies that A0, and I am putting the value of B0 here. A0, A1 minus, 2A0 minus a1 square. 1. So now observe one thing. These both this term and this term both are integers, and their product is 1. So the only possibility is that the modulus of this thing is 1 and the modulus of this thing is 1. Sorry, it is minus 1. So about the sign, we will consider later, but they will be opposite sign, obviously. So modulus of a0 a1 equal to modulus of 2a0 a1 square, that both are 1 and of opposite signs. Fine. Now again, this term is product of two things, and it is a magnitude is minus 1. So either this is 1, this is minus. So there are multiple possibilities. Okay, 1 minus 1 minus 1 minus 1 1 1 and minus 1 1. So what is the correct choice? I need to put the value and see which set of a0 and 1 satisfies this. For example, if I take, if you see a0 equal to a1 1, then we have what we have, put a0 equal to a1, you will get 1 equal to minus 1, which is false, contradiction. If so, it is impossible. So we will discard this possibility. What are the remaining possibilities? If a0 equal to a1 equal to minus 1, both are minus 1, then if both are minus 1, then this thing will give you 1 into minus 2 minus 1 equal to minus 1. But this string is actually minus 3. So again, this is impossible. So again, this is impossible means I will discard this possibility also. Next, so there are two possibilities are still left. Let me check. If a0 equal to 1 and a1 equal to minus 1, then that is a possibility. Then if I put them in that equation, I will get, what was the equation? I forgot. a0 a1, huh? Then it will be a1 to a0, 2 minus a1 square 1, which is actually possible. It is true fact. So that is a solution. That is an accepted solution set. 1 comma minus 1. Sorry, this is hanging. So it is 1 comma minus 1. You can accept without any ambiguity. Lastly, what is the remaining possibility? If a0 equal to minus 1 and a1 equal to 1, then also you will get contradiction, impossible fact. Then minus 1 equal to 2a0. What was the equation? 2a0. 2a0 means minus 2 and minus a1 square, right? Minus a1 square means minus 1. So it is 3. So it is equal to 1. This is impossible. Equal to 1. Impossible. Because this is actually equal to 3. So the solution is a0 equal to 1 and a1 equal to minus 1, if I am not mistaken. Yes. And then what is b0 and b1? I have a relation there. So b0 and b1 can be determined in terms of a1 and a0. b0 is actually from there I can directly determine what is B0. B0 is minus 1 by A0. Then B0, this is minus 1 by A0. This is minus 1. And B1, what about B1? What was B1 here? B1 was here, that thing. But these two are same. So B1 will be 0. And B1 is 0. Now from this equation, I will help, lastly, that is my last thing to utilize this equation. Sorry. Sorry for the underline. Let it go. Last, my formality is use this equation. So if I use this equation, the equation is A0 B1 plus A1 B0 and put the all values there. So the equation, what was the equation? A0 B1 plus A1 B0 equal to minus A. We get minus A equal to A0. So B1 is 0. A1 is minus 1. B0 is again minus 1. So it implies that minus A equal to plus 1 or A equal to minus 1. This one, so that was the only solution. So our proof is complete. Okay, so our proof is complete here. Because why it is complete? Because the values you need to show was, sorry. So the values 0 to minus 1. So 0 and 2 are previously shown. Only minus 1 was awaiting. But this is the total technique how to obtain minus 1. Okay. So if we stop my class here.